Self-exercise 8.1, questions 1. A particle moves along a straight line and passes through a fixed point O. Its displacement, as meter, is given by s equal to 2t squared minus 5t minus 3. A. Find the instantaneous displacement in meter of the particle when, number 1, t is equal to 0. To find the instantaneous displacement, we just need to substitute the times into the displacement equations. So for A1, it will be s equal to 2 times 0 squared minus 5 times 0 minus 3, which is equal to negative 3. This means the particles is 3 meters on the left-hand side of the fixed point O. For A2, when t is equal to 2, then the displacement will be s equal to 2 times 2 squared minus 5 times 2 minus 3. This is equal to at minus 10 minus 3, which is equal to negative 5. This means the particles is at 5 meters to the left-hand side of the fixed point O. Questions B. Finds the time when the particle, number 1, passes through point O. So when the particles is at point O, the displacement s is equal to 0. So to find the times, it will be 2t squared minus 5t minus 3 equal to 0. As this is a quadratic equation, to solve this, we're going to use the factorization method. So the first bracket will be 2t plus 1, and the second bracket will be t minus 3 equal to 0. Then t is equal to negative 1 over 2. Another t will equal to 3. As t is referred to the times, so the times cannot be negative. Then we're going to reject the answer t is equal to negative 1 over 2. Then the correct one will be t equal to 3. Number 2, when the particle is 9 meters to the right of point O. This means the s is equal to 9. To find the time, it will be 2t squared minus 5t minus 3 equal to 9. So to solve this, I'm going to write this in general form for these quadratic equations. It will be 2t squared minus 5t, so negative 3 minus 9, this will be negative 12. This is equal to 0. Again, using factorization method, we're going to get t minus 4, another bracket is 2t plus 3 equal to 0. So t is equal to positive 4, another t will be negative 3 over 2. So remember, the times cannot be negative. Therefore, we're going to reject the answer t is equal to negative 3 over 2. And the correct one will be t equal to 4. Question C. Determine the range of time in seconds when the particle is to the right of point O. So when the particles is on the right hand side of the point O, the displacement is always positive. Therefore, the s is greater than 0. So to solve this, this will be 2t squared minus 5t minus 3 greater than 0. So this is a quadratic inequalities. Factorize this, we're going to get t minus 3 and 2t plus 1 greater than 0. So now using the graph method, so based on the factorizations, when s is equal to 0, the value of t is equal to positive 3 and the other one is negative 1 over 2. So when we label it on the graph, here will be the negative 1 over 2 and here will be the 3. As this quadratic inequalities is greater than 0, then the range will be above the t-axis. For the times, it cannot be equal to negative, then we're going to ignore this part, and the correct range will be t greater than 3. Questions number 2. A particle moves along a straight line and passes through a fixed point O. its velocity v meter per second is given by v equal to t square minus at plus 7, where t is the time in seconds after passing through O. A finds the instantaneous velocity of the particle when t is equal to 3. To find the instantaneous velocity, we just need to substitute the times given into the equations of the velocity. So for A, it will be velocity v equal to 3 square minus at times 3 plus 7, which is equal to 9 minus 24 plus 7, which is equal to negative 8. B. Calculate the values of t in seconds when the particles stop instantaneously. So when the particles stop instantaneously, the velocity of the particles is equal to 0. So to find the t, it will be t square minus at plus 7 equal to 0. So here we can use factorization method to solve these quadratic equations. It will be t minus 7, another one is t minus 1 equal to 0. Then t is equal to 7 or t is equal to 1. So this means the particles stop instantaneously 2 times at t equal to 1 and at t equal to 7. Question C. Determine the range of value of t in seconds when the particles move to the left. So when the particles move to the left, the velocity v is less than 0. To find the range, it will be t squared minus at t plus 7 less than 0. So factorize this, t minus 7, t minus 1 less than 0. So when v is equal to 0, the t is equal to 7 or t is equal to 1. So to solve these quadratic inequalities, we're going to use the graph method. So here will be the number 1 and here will be the 7th. As the quadratic inequalities is less than 0, then the range will be below the t-axis. Then the range of value of t will be t greater than 1 but less than 7. Question 3. A particle moves along a straight line and passes through a fixed point O. Its accelerations a is given by a equal to at minus 4t. A finds the instantaneous accelerations of the particle when t is equal to 4. To find the instantaneous acceleration, we just need to substitute the times given into the equations of the A. So the instantaneous acceleration will be a equal to at minus 4 times 4, which is equal to at minus 16 equal to negative 8. Questions B. Calculate the times in seconds when the velocity of the particle is maximum. So let's say the parabola here represents the velocity. So when the velocity is maximum, so at the maximum points here, the dv dt, this is equal to 0. As dv dt, this is equal to accelerations. Then when the velocity is maximum, a is also equal to 0. So to find the time, it will be at minus 40 equal to 0. Then 40 is equal to 8. Then t is equal to 8 divided by 4, which is equal to 2. Question C. Determine the range of time in seconds when the velocity of the particles is increasing. Let's say this curve represents the velocity of the particles. And this dotted line is the axis of symmetry. For the part on the left-hand side of the axis of symmetry, which is here, this is when the velocity of the particles is increasing. The tangent of the curve, which is the dv dt, for the part when the velocity of the particles is increasing, is always positive. As dv dt is also equal to the accelerations, then we can say that The A is greater than 0 when the velocity of the particles is increasing. To solve this, it will be at minus 40 greater than 0. Then negative 40 greater than negative 8. Then t is less than negative 8 divided by negative 4. So here the inequality signs will be reversed as we divide it with a negative number. Then t is less than positive 2.